Hi, I'm JoonHo.
And I'm Melvin.
We're from Math 271.
And today we'll be doing our assignment 1, which is chapter 13.2.
Integrals of vector functions, projectile motion.
So for today, our question is hitting a baseball under a wind gust. A baseball is hit when it is 2.5 feet above the ground. It leaves the bat with an initial velocity of 145 feet per second at a launch angle of 25 degrees. At the instant the ball is hit, an instantaneous gust of wind blows against the ball, adding a component of negative 14I to the ball's initial velocity. A 15 feet high fence lies 300 feet from home plate in the direction of the flight.
Given information, from the passage, we can get that the initial position of the x is 0 feet, the initial y position is 2.5 feet, initial velocity is 145 feet per second, velocity of the wind is negative 14I feet per second, and the launch angle is 23 degrees.
So for part A, we have to find a vector equation for the path of the baseball.
This is the general formula for the position vector, RT, which is for the x component, x naught, v naught cos alpha minus v wind times t, I plus y naught plus v naught sine alpha t minus half gt squared y j. So you plug in all the given values into this formula, and the final position vector becomes 145 cosine 23 degrees minus 14 ti plus 2.5 plus 145 sine 23 degrees t minus 16 t squared j.
So for part B, how high does the baseball go and when does it reach maximum height? So for this, we could use the formula given, which is v naught sine alpha squared over by 2g. But in this case, we have to add 2.5 because the ball is struck at 2.5 feet above the ground. So then after this, we get 145 sine 23 to the power of 2 over by 2 times by 32 plus 2.5. You're probably wondering why g is replaced by the number 32. This is because it is in feet and not meter per second. So after that, we will get a grand total of 50.2 plus by 2.5, which would be 52.7 feet. Also, we could use the y component method to find the height.
First, we differentiate the y component of the position vector to get the velocity for the y component, which is 145 sine 23 degrees minus 32t. When we equate this as 0, you can find the maximum height. And you solve for t, and t becomes 1.77 seconds. And you plug this into the y component of the position vector, and you can get the maximum height to be 52.65 feet, which is almost identical to the one that was found through the height formula.
Now we move on to part C, which is finding the range and flight time of the baseball, assuming that the ball is not caught. As from the question states, assuming that the ball is not caught, so therefore y will equal to 0 as it lands on the ground.
And by using the quadratic formula, you can solve for t and plug the given information in the quadratic formula as shown in the screen. And you can solve that t is equals to negative 0.043 seconds and 3.58 seconds. But we cancel out the negative seconds because time cannot be negative.
So t equals to 3.58 seconds. So we are going to plug this in into the x component to find the range. So we have 145 cos 23 minus 14 times by 3.58, which would give us 427.71 feet.
And we can use the range formula, which is v naught squared sine 2 alpha over g. But in this case, we have to minus 14t because there's a gust of wind blowing against the velocity of the ball in the x direction. So when you plug in all the given information, the range becomes to be 422.4 feet, which is slightly lesser than the one found from the x component equation, but it's close enough.
Now moving on to part D. When is the baseball 20 feet high? And how far in ground distance is the baseball from home plate at that height? We have to understand that the baseball will reach 20 feet twice as when it's accelerating upwards and when it's decelerating downwards.
And we use the y component for the position vector formula, position vector equation, and equate it to 20 because baseball, you have to find when the baseball is 20 feet high. And then you move the 20 over, then equate it to 0 to use the quadratic formula to find t, because we're looking for when, which is time. And t will become 0.34 seconds and 3.2 seconds.
So as mentioned above, there is twice when the ball reaches 20 feet high. So in this case, we have to use both the times. So in this case, we're going to use 0.34 first. So the x component would be 145 cos 23 minus by 14 times by 0.34, which would give us 40.62 feet. And secondly, we have the 3.2 second, which would give us 382 and 31 feet.
So these two distances are how far the baseball is from the home plate at that height, at 20 feet above the ground. And lastly, for part E, has the batter hit a home run, and explain.
In this case, yes, because according to part D, the ball is still 20 feet above the ground when it is 383 feet from home plate. As given in the question, that the fence is only 15 feet above ground, so therefore we can assume that a home run has been made.
And the fence is only 300 feet from the home plate, so the ball would have surpassed the distance by that. Thank you for watching our video.
We hope you tune in for our next assignment, and we hope you have learned as much as we have learned from this equation. Thank you very much. We'll see you soon.
Bye.